Good morning, Honors Algebra 2 students. This is Mrs. Casello, and I wanted to go through some of the problems in 822, what are complex roots. So you should have learned about complex roots, what we get when we set the equation equal to 0, but these roots have both a real and imaginary part. So I'm going to start with 881. The direction said in parts A through D, look for patterns as you calculate the sum and product for each pair of complex numbers. So remember, sum, you add them up, product, you multiply them. So the sum's pretty easy. So for the first one, the sum would be 4 because the i's cancel out. Now, I strongly suggest, if you guys look at my work here, for all the products, I love using a generic rectangle, just helps out with those i's. So as I multiply this together, I get 4, I get a negative 2i, a positive 2i, and a negative I squared. So the plus and minus 2i cancel out, so I'm left with 4 minus I squared. Well, since I equals the square root of negative 1, this is the same as saying 4 minus a negative 1. Because when we square I squared equals negative 1. So then this product simplifies to be 5. So then for letter B, when I find the sum and add them up, I get 6. When I find the product, I get 9 minus 15i. Sorry, it's my dog. Plus 15i. Awesome! Minus 25i squared. So it's 9 minus 25i squared, which turns into a plus 25, because it's like 25 times negative 1. So 9 plus 25 is 34. So then as you see for part C, the sum is negative 8, the product 17. Then for part D, the sum is 2 and the product is 4. So then as we move down to part E, it says what complex number can you multiply 3 plus 2i by to get a real number? So if you kind of looked at the pattern up here, I hope that you saw it should be 3 minus 2i. All right? So if you take a look at part F, you notice those numbers, the negative 4s are the same, but you have a positive 5i and you have a positive 3i. So when we multiply these together, are we going to get a real number? So we get a positive 16 minus 12i minus 20i, and then we get a 15i squared. So again, that I squared is negative 1, so this is really negative 15. So 16 minus 15 is 1, and negative 12i minus 20i is a negative 32i. So you notice this is still a complex number because it has an imaginary part. So then finally part G says, what complex number can you multiply a plus bi by to get a real number? So a plus bi times a minus bi gives you a real number. And the name of this pair of numbers is called complex conjugates. Now the reason I want to go through this table first is now I want to jump to 886. All right, before you go through 886, make sure you've completed 883, 84, and 85 because it goes through all of these. So the directions say for each pair of numbers below, find a quadratic equation that has these numbers as solutions. So I'm going to show you the 3 methods that you should have learned in those 3 problems. So for the first one, for 3/4 and negative 5, why don't we work backwards? And that's like problem 885. So I'm going to set x equal to what the zeros are, okay, or solutions. So for this one, I want to go ahead and set this equal to 0. So the first thing I'm going to do to both sides is multiply by 4. So I get 4x equals 3. So the factor that this came from, so subtract a 3 over to the other side, is 4x minus 3. This one's a little bit easier. Just to get the negative 5 on the other side, we add it. So this factor is x plus 5. So now to get the quadratic, we just need to take 4x minus 3 times x plus 5 and set that equal to 0. So when I multiply this guy out, I get 4x squared minus 3x plus 20x minus 15. So then my final answer is 4x squared plus 17x minus 15 equals 0. All right, so that was just working backwards, setting x equal to those numbers, undoing it to set that factor equal to 0, and then multiplying it out. All right, now the next method is using the factors like 884. All right, so if you look back to that problem, this is the same idea. So this time I'm going to take x minus the solution. So x minus 3i, and be careful here, x minus a negative 3i. So that's really x plus 3i. So as I put those factors, and again, I really like the generic rectangle to multiply, it just keeps it organized. All right, let's multiply this together and see which quadratic is going to result with this multiplication. So I get x squared, 3ix, negative 3ix, negative 9i squared. Again, that's negative 9 times a negative 1, so it's actually positive 9. And since these are complex conjugates, the I terms cancel, so we are left with just x squared plus 9 equals 0. All right, so when it's only just an I term, it's pretty easy. All right, and now let's take a look finally at part C. Part C, I want to go back to what we learned about using the table of the sum and product. So if you notice with the sum and product here, maybe there was a reason why we did that each time. So if you take a look at part C, 5 plus 2i and 5 minus 2i, the sum is 10, the product is 29. All right? Well, I could go through and use some of the methods I did in parts A and B, and you would get the same answer, but here's what's kind of cool. When you have complex conjugates, the sum is the coefficient with the x term, but it's the opposite, and the product is your constant term. All right, so the neat thing is here, I actually didn't even work backwards. I used the pattern that we learned in the table to go ahead and find the quadratic. So then finally, I would suggest you guys try part D using any method, or maybe try 2 of them, okay? So that was just explaining 881 and 886. Please make sure you finish up lesson 822 and then do the 821 and 822 concept checked. So, all right, thanks guys.